Hello and welcome to 5 Minute Math. Today we are looking at the 8th grade readiness practice for 8.2D, the proficient version. If you are interested in exploring the 8.2D readiness practice for the intermediate or advanced versions, or the 8th grade readiness practice for any other standard, you can find those by using the link in the video description. So we've got four different values here. We need to range them from greatest to least. And then we also need to identify which two values are closest to each other on a number line. So we'll be using our calculator quite a bit. Let's go ahead and get some values for each of these. And I'm going to take them to let's go to the thousandths place. So the square root of 62 is going to be, and I'm going to put the wavy equal signs. That means approximately 7.874. 7 and 4/5, I don't really need to use the calculator. You can if you need to, but 4/5 is going to be 0.8. So we'll do 7.8, and I'll go ahead and just make it the thousandths plate as well, so we can keep up with that. 7.85 is literally 7.85. Once again, we'll make that to the thousandths place. And then 63 over 8. All right, let's use the calculator for that. So 63 divided by 8. 7.875. All right, so first, let's go ahead and get these on a number line. And they're all going to be between 7 and 8. Honestly, they're all going to be between 7.5 and 8. So I'm just going to make those my two boundary numbers here. And they're not going to be perfectly spaced, but we'll get close. All right, so my least number is going to be that 7 and 4/5, because you see it's 7.8000. They all go to the 8, so really I'm just looking at this third digit that's in the hundredths place, and the 7.0 is going to be the lowest, and so I'm going to put that, we'll call that right here. I'll put the decimal value that I've been using underneath, and then I'll put the actual value, because honestly, if this were a star test, that's what they would give you. They'd give you the 7.7 and 4/5. They wouldn't give you the 7.8000. All right, so that's going to be my least. My 7.85 is going to be next. So I'll put that right next to it, 7.85, 0, and then 7.85. Now, the last two, I'm going to have to get pretty close because look, 7.87, 7.87. One is a 7.874, one is a 7.875. So those two are going to go right next to each other. And I'm going to kind of run out of room, so I'm going to put that down there. 7.874, which is the square root of 62. And then my 7.875, which is the 63 over 8. So here is my list, right, from least to greatest here. And since we're needing it from greatest to least, what we want to do is we want to take these, and we'll go ahead and put a separate answer box down here for our two things. So let's go ahead and put our greatest to least. Because remember, when we do our number lines, right, from left to right, they're automatically going to be least to greatest. So if that's what you need it in, that's fine. But in this case, we need greatest to least. So we're going to use that tool, but we need to go ahead and reverse it. And that's why we went ahead and put it in the original form. 63/8 square root of 62, 7.85, and then 7 and 4/5. Now, we need the two values that are closest to each other, right? The 7.80, look at this. The 7.80 is 5/10 away from the next one, and then 7/10 away from these other ones, right? So it's not going to be that and this. I'm really thinking it's going to be these two, because look, 7.874, 7.875. That's like 1/1000th away from each other. Those are the two closest to. So we also need to go ahead and just label those two, and I'll do that in a different color, right? And I'll say two closest. And it's going to be the two that ended up as the 7.87. So 63 over 8 and square root of 62. All right, so that's it for that problem. For our second problem, we are looking at a construction team, right? They're building something and they're cutting steel beams, and here's some different values for the area and the length of the four beams. We need shortest to longest, and then we've got another question about what was within tolerance. Let's do the same thing. Let's get some values. So square root of 0.5. So I'm going to go ahead and put my equivalents there, because that is not going to be an exact number. All right, so that's going to be 0.7071. We'll just stick it with 707. All right, 2/3, we should know that, right? That is, I'm also going to, uh, I'll put the equal sign here, but really it's 0.666 repeating, right? And so it's going to 6 forever. Sometimes you might see it as 0.667, but then that'd have to be an equivalent sign. So it's that last 6 is, it just 6 forever repeats. 0.6 is literally just 0.6. Let's put 2 zeros there. 65%. Now, percent means per 100. So 65% means 65 per 100 or 65 hundredths. So you can just go ahead and put 0.65 and add that 0. All right, so we're going to go ahead and put our number line here. And so we can go ahead and do that. And it looks like we're going from 6 to above 7. So we need a little bit of a bigger number line here. So we're going to put 0.6, and then let's put 0.8. Put a midpoint of 0.7, just because I'm already look at that square root of 0.5 is already going to be above. That's going to be 0.707, or square root of 0.5. That's going to be my biggest. Obviously, I've got my 0.6 like right here. I'm just going to circle that, but it's one of the boundary numbers. So there's only two other numbers I need to put in there, the 65% and the 2/3. At 65%, it's going to be halfway between the 0.6 and the 0.7. So I'll just put 0.650, or 65%. And then my 2/3 is going to be a little bit more than that. So 0.666 repeating, or 2/3. So there's my order. Now this automatically does give me the least to greatest. Remember, all number lines, if you do them correctly, will get you your least to greatest. So we can just go ahead and copy that down, because least to greatest is the same thing from shortest to longest. So we did have to interpret that a little bit, but shortest is the least, longest is the greatest. So we're going to put 0.6, 65%, 2/3, and then square root of 0.5. Now let's look at this second question. All right, a beam is considered within tolerance if its error is less than 0.62. Okay, where is 0.62? Well, 0.62 is going to be like right here, maybe 0.62. So which beams are within tolerance? Well, it looks like there's only one that's less than that. It has to be less than 0.62, not less than or equal to. All the others are greater than that. So it is just going to be that 0.6. So within tolerance, let's add that here. And that's going to be 0.6. It's the only one. For problem 3, we've got 4 different values. It looks like they are going to be improper fractions or greater than 1. We need to create a number line, plot each point, and then write a compound inequality using a symbol showing the relationship. All right, so we'll see that sometimes in our answer selection. So let's build the equivalencies, and then we'll build those in the compound inequality. All right, so 12.5, I'm assuming we're just going to go to the thousandth place, so I'll just do that. Ooh, square root of 150. Definitely need the calculator on this one. All right, so that's going to be equivalent to 12.247. Now look at that, 4 in the 10,000ths place. It almost made that 7 and 8, but we'll just leave it as a 247. It's getting pretty small at that point. So 12 and 3/8 is going to equal 12 and something, and 1/8 is 0.125, so 3/8 is going to be 0.375. You can check me on the calculator if you don't believe me. And 121 over 10. We can also do this without the calculator. When you divide by 10, you're just moving the decimal over one time. So it's 121 with the decimal moved in once, so it's 12.1. Because we have a 10 base system, we can add 2 zeros. All right, so let's create a number line. We're going to plot each point. And it looks like I'm between, you know what, to give ourselves room, let's do between 12 and then 12.5. And we'll just have 12.5 be one of the endpoints. So that's there. We've got 12.5. My smallest is going to be the 12.1. So we can put that right here, 12.100. And the actual is 121 over 10. We've got 12.247 is going to be next. So 12.247. And that's going to be the square root of 150. And then my 12 and 3/8. So 12.375 or 12.3/8. And then let's get my 12.5 up here. That's one of mine. Now, that's the easy part. We also need to write a compound inequality. Now, that might not seem like something that you've done before, but you've seen it a lot. Because look, what we want to do is we want to write these in order. Since I'm using a less than symbol, what I want to do is I want to put a series of less than symbols. And I just want to list them in order from least to greatest. If you're using the greater than symbol, you would do it from greatest to least. So what's my smallest? 121 over 10 is less than square root of 150 is less than 12 and 3/8 is less than 12.5. It looks like I put an extra decimal there. I did not. So there we go. Let's get that out of there. 12.5. And there we go. That is our compound inequality.